So here in this question, we're asked to use the substitution x is equal to u squared plus 1 to show that the integral from 5 to 10 of 3 divided by x minus 1 multiplied by 3 plus 2 lots of the square root of x minus 1 integrated with respect to x is equal to the integral with limits from p to q of 6 over 3 plus 2u with respect to u. And we're told that p and q are positive constants to be found. So here, what do we need to do? We are wanting to do integration by substitution. So how do we begin this? Well, we know that the substitution that we've been asked to do is to use x is equal to u squared plus 1. So what do we do here? Well, what we're going to do is we're going to rearrange for u, and then we're going to differentiate that, and then that will give us an expression in terms of dx, which we can then substitute back into our original expression, and then we'll aim to replace these x's here with u, which will then get into some sort of form which we're after. So therefore, we're going to say that u squared is going to be equal to x minus 1, and therefore we can say that u is going to be equal to the square root of x minus 1. And this is good because we can see here we have the square root of x minus 1, which will in just a few seconds be able to substitute in u for this. So therefore we have that du is going to be equal to this term differentiated. So we know that that is going to be equal to 1 divided by 2 lots of x minus 1, and this is with respect to x we've differentiated. So therefore we'll rearrange this to find for dx. So this is going to be dx is going to be equal to 2 lots of x minus 1 multiplied by du. So that's good. This is what we can now substitute into this equation here. But first we can also find our new limits. So I'll just write this down here. New limits. So the limits that we have currently, 10 and 5, they are with respect to x. So we need to find them with respect to u. So we'll have that for x being equal to 5, we'll have that u is going to be equal to the square root of x minus 1, so we'll have 5 minus 1, that's going to be the square root of 4, which is going to be equal to 2, and then we're going to have for x being equal to 10, we're going to have that u is equal to the square root of 10 minus 1, and we square root that, and that is going to be equal to the square root of 9, which is equal to 3. So this is our new limits here. So I'll just annotate that in, new limits. And then what's left for us to do now? Well, we want to take all this new information that we have and substitute it back in to our original equation. So what we're going to have, we know that this is going to be equal to, so we're going to have an integral, but this time it's going to be limits from 2 to 3. And we see that we have a square root of x minus 1 here, so we can substitute this with u, and then we also know that x is equal to u squared plus 1, so we can substitute in u squared plus 1 here. So then we also know that dx is going to be equal to 2 lots of the square root of x minus 1 multiplied by du. So just writing this in purple here, these 3 bits here, that is just going to help us be able to visualize what we're about to substitute in. So we're going to have 3, and it's going to be divided by u squared plus 1, and then we take away 1, and that all stays in this bracket. And then we're going to have, that is going to multiply by 3 plus 2 lots of u, and then we're going to multiply all of this by 2 lots of the square root of x minus 1, which is going to be equal to 2 lots of u, so we have 2u du. So then simplifying this fraction, we have u squared plus 1 minus 1, that is going to be equal to u squared, and then we can just tidy this up here. We can take our 2u and multiply it by 3, so we have our 2u multiplied by 3, so that's going to be equal to 6u, and here we go. So then therefore, simplifying it one step further, our limits 2 to 3 stay the same. We can then divide everything by u. So we're going to have 6. And we're going to divide that by, this is now u, lots of 3 plus 2u. And this is all with respect to u. So we now take a look back at our question. What were we being asked to find? So we were being asked to find 6 divided by u, lots of 3 plus 2u. And that's what we have here. So therefore, we have got this into the form that the question asks for. So we'll write here, this is going to be as required, and we're asked to find constants P and Q. So we'll just put a little note down saying we've found this with P equal to 2 and Q equal to 3. This question was worth 4 marks and we receive our first mark for starting our substitution and getting an expression for dx. So we'll give our first mark at this stage here. We then receive our second mark for doing the full substitution into our expression for the integral. So that's at this stage here. We receive that. We then receive our third mark for working out our new limits. So that was substituting our x limits into our expression for u in terms of x, which gives us 2 new limits. And then we receive our fourth and final mark for having the answer which the question asks us for and having a concluding statement saying that we got to the required answer. So in the next part of the question, we're asked to use algebraic integration to show that our integral from part A, so the integral of 3 divided by x minus 1 multiplied by 3 plus 2 lots of root x minus 1 integrated with respect to x from the limits 5 to 10 is equal to ln of a, where a is a rational constant to be found. So first of all, it's safe to say that we know from part A that this expression we're given in the question is going to be equal to our answer which we've shown in part A. So we have that this integral is equal to the integral of 6 over u lots of 3 plus 2u integrated with respect to u with the limits from 2 to 3. So this is a good first step. So the next step for us is going to be to make use of partial fractions. So we'll just write this down here. So we have partial fractions. So therefore, forgetting about the integral for the minute, we can say that 6 divided by u lots of 3 plus 2u. So we know here we can split this up into effectively u and 3 plus 2u. So that's our two factors on the bottom. This is going to be equal to a divided by u. And then we're going to add on b divided by 3 plus 2u. So we now need to find what the constants a and b are going to be. So how are we going to do this? So we're going to multiply both sides by u lots of 3 plus 2. So therefore, this is going to leave us with the fact that 6 is going to be equal to a lots of 3 plus 2u, and then we're going to add in b lots of u. So then what we can say is if we let u equal 0, we'll have that 6 is going to be equal to 3 lots of a plus 0 lots of b. So that then means here we can say that a is going to be equal to 6 over 3, which is 2. And then if we now let u be equal to 1, we're going to have that 6 is going to be equal to, so here what do we have? So we now know that a is 2, so we're going to have 2 lots of 3 plus 2 lots of 1. So that is 3 plus 2, 5, multiplied by 2, so we're going to have that that is equal to 10. And then we're going to add on b multiplied by u. U is now equal to 1, so that's going to be plus b. So then what does this leave us with? So this is going to leave us with the fact that b is going to be equal to 6 minus 10, which is equal to minus 4. So therefore, what can we say? So we can say that, well, we know what this expression is going to be equal to. So we have as follows. So we copy down our expression from above, and we've worked out that a is equal to 2 minus 4 over 3 plus 2u. So therefore, what we can do now, remember we're wanting to use integration here. So what we can do is we know that this here is equivalent to this. So then if we take the integral of it, we know that this is also going to be the equivalent of 3 and 2. So now we know how to integrate this. So we integrate with respect to u. We know that the integral of 2 over u is going to be 2 lots of ln u. So then for this second term, we are going to have, I'll just write it off to the side here. So we're going to have the integral of negative 4 multiplied by 1 over 3 plus 2u du. And what's this going to be equal to? So it's going to be equal to negative 4, and then we multiply that by ln of 3 plus 2u, And then we must also divide by 3 plus 2u differentiated, which is equal to 2. So therefore, that's going to be equal to negative 2 ln 3 plus 2u. So then we substitute this back into our expression. So that's going to be negative 2 lots of ln 3 plus 2u. And then we still have our limits to put in. So we put our brackets around this here, and we have 3 and 2. So then therefore, we'll just keep our equal sign going down. So we'll have 2 lots of ln of 3 minus 2 lots of ln of 3 plus 2 multiplied by 3, which is going to be ln 9. And we have kind of bigger brackets around here. Then we're going to subtract the same again, but with the limit 2 put in. So that's going to be 2 ln 2. And then this time that's going to be minus 2 ln of 7. So what can we do now? So we'll continue our working, and we'll just do it over here slightly to give us a little bit more room. So we can say, we know the log law, we know that if we have ln of a to the power of b, that is going to be equal to b ln of a. So if we have 2 lots of ln of 9, that's going to be equal to saying we have 2 lots of ln of 3 squared, which is equally equivalent to, we can bring this power down here, and we'll have 2 multiplied by 2, which is 4 ln of 3. Then we have 2 ln of 3 minus 4 ln of 3, which is going to be equal to minus 2 ln of 3. So we'll have minus 2 ln of 3. Then we'll take a look at this expression on this side. So we'll multiply everything by minus 1, which is going to leave us with minus 2 ln 2, and we're going to add on 2 ln of 7. So remember, what we're looking for here, we're looking for something ln a. So we need to now use log laws to combine these. So we know that log of a plus b is equal to log ab, and we know that log of a minus b is going to be equal to log a over b. So therefore, what can we do now? Well, we can have a look at our first term, and we're going to have that this is going to be 2 ln 7, and we can do one subtraction, so we'll have 2 ln, and then let's go for 7 over 3, and then we'll still have our second term, which is 2 ln of 2. Saying the same again, we can then have that this is going to be equivalent to 2 ln of 7, and then we will have 3 multiplied by 2, and then we can simplify this further, which is going to be 2 lots of ln of 7 over 6. So remember, we were asked to give something in the form ln a, but we currently have a constant multiplied by ln a. So what can we do? From this log law here, we can bring this power up here and square everything. So that's going to be equal to saying that we've got ln lots of 7 over 6. And then we square all of that. So we square both terms, which is going to be equal to ln 49 over 36. And then that is equal to ln a, where a is equal to 49 over 36. So therefore, we've completed this question. This question was worth 6 marks, and we receive our first mark for knowing to use partial fractions and stating the values of a and b. So we received this when we stated our values for a and b, so at this stage here. We then received our second mark for having the correct partial fractions. So that was having 2 over u minus 4 over 3 plus 2u. So we received that second mark at this stage here. We then receive our third and fourth marks for firstly, knowing to integrate, and secondly, integrating correctly. So this is at this stage here when we substitute our limits in. So we're going to note down that we received 2 marks here. We then received our fifth mark for using our limits and getting to the stage using the correct method to get 2 lots of ln 7 over 6. So that was at this stage here where we got this mark, and then we receive our sixth and final mark for having the correct answer, which was ln 49 over 36. And we received that mark here.